Hello and welcome to this video on how to use the chain rule. Now, chain rule is quite an interesting and useful feature because it allows you to differentiate things that you may not be able to differentiate normally. We're going to take an example of y equals 6 4x plus 2 to the power of 9. Now, in conventional differentiation, you're right, this is a nightmare to try and differentiate, but because we know chain rule, we can differentiate it. We're going to make u equal to 4x plus 2, and thus we're going to write now as y equals 6u to the 9, u equals 4x plus 2. Then we're going to differentiate each term, so dy by du is going to be 54u to the 8, and du dx is going to be 4. Then we can combine the two together, so we have 54u, well, a bit bigger, 54u to the 8 times 4 equals, what is it, 216, 216u to the 8. And then we can substitute 4x plus 2 back in, so our final answer is 216 4x plus 2 to the 8. That's one example. Now, I'm sure you'll probably want another one, so we'll give you another one. And we are going to take the example of this one because this is a bit harder. Y equals 4 ln 8x plus 1. So again, even though it's got ln in, as we know, we can differentiate ln. So we can write this again as y equals 4 ln u, and then we can have u being 8x plus 1. So differentiate each of them in turn, dy over du equals 4 over u, and then u is going to just be 8. So we can do 4 over u times 8, which is going to be 32 over u, substitute it back in, so it's 32 over 8x plus 1. Thank you very much for listening. I hope this was useful, and if you just want a quick recap, I'll go through it quickly. Basically, to convert, just take out the bits, so you've got a y bit in terms of u and a u bit in terms of x, differentiate them both and then put them back together. Thank you very much for listening.